Hi, this video is all about acceleration directions. The direction of acceleration indicates how the velocity is changing, not the movement direction. It's an easy thing to mix up. Positive acceleration means the velocity is becoming more positive or the velocity is becoming less negative. Negative acceleration is when velocity is becoming more negative or less positive. Let's look at an example to make this make sense. Let's say we have a bicycle rider moving at 10 meters per second east, and she slams her brakes to avoid hitting a turtle. So, which direction is the acceleration in? Well, to understand this, we're going to use my patent pending velocimeter here. And this velocimeter shows the speed of an object, but not just its speed, but also its direction. Remember, velocity is speed and direction. So unlike a normal speedometer, which just shows the speed, this one can show the speed and what direction you're moving in. So on the left side, we have negative directions. And on the right side, we have positive directions. Okay, so this girl is moving at it says 10 meters per second east. Now, normally when we talk about east and west, we imagine east is to the right and west is to the left. And because of that, tradition has it that we say east is positive because on a number line, to the right is positive and west is negative. So there's nothing wrong with the west direction. Just because it's negative doesn't mean anything about its value. All it means is it's to the left. And so in this case, the girl has an initial velocity that is positive. So we would indicate that on our velocimeter by moving the meter to the positive 10. Now, if she was moving to the west at 10 meters per second, she would have a velocity of negative 10. So over here, it doesn't mean you're stopped or not moving or slow. You could be going really fast, but in the negative direction. In this case, she's moving east, so she's going positive 10 meters per second. All right, it does say that she slams on her brakes, and so she goes from a positive 10 velocity to a 0 velocity very quickly. So notice the direction I moved this needle in. It goes from positive 10 to 0. All right, so notice that I'm moving the needle towards the negative end of the velocimeter. It's becoming less positive, and so the acceleration is negative. She's slowing down because she was moving with a high positive velocity. Then she starts slowing down to 0. I don't know if my needle is lining up very well. I made this in about 30 seconds. So she's slowing down to 0. All right, let's look at another example. This time, let's say a skydiver falls to the earth, starting from rest, and reaches a velocity of 20 meters per second downward. So I've drawn my skydiver here. He's moving down at a velocity of 20 meters per second. If you look at my number line now, it's up and down. It's a vertical number line. And so it's different than the horizontal one here. Usually vertical, it's pretty easy to see why down means negative direction and up means positive direction. So if I can put the 0 anywhere on my little number line here. If I'm going this way, I'm going in the positive direction. If I'm going down, I'm going in the negative direction. So right now, the skydiver is moving at a velocity of negative 20 meters per second. Now, that's not what he started out at. Remember, it says he started from rest. So he started here at 0. All right, there we go. Started at 0, and he began speeding up towards the earth. But he's speeding up, moving in the downward direction, and that's why his velocity goes this way on the velocimeter. He's going in the negative direction. So he's going very fast, but it's negative direction moving down. So look at the direction of the acceleration again. It's going from 0, but it's becoming more and more and more negative. So the acceleration direction, it's moving this way, it's negative. But he's speeding up this time. So you can have a negative acceleration, but you're actually speeding up if you were moving down or if you're moving to the west. If you're moving in a negative direction and you have a negative acceleration, that means you're going to get faster and faster in the negative direction. So don't think of negative acceleration as slowing down. It doesn't necessarily mean that. It can, but it doesn't necessarily mean that, because what matters is where was your velocity at the beginning. And if you're moving in the negative direction on this velocimeter, you have a negative acceleration, but that could mean you're actually getting faster because zero speed is here at the top. You're getting faster and faster moving away from zero. And so negative acceleration can mean speeding up. All right, let's look at another. Let me show you all of these examples summed up in a chart here. So this chart shows for different initial velocities and accelerations what's happening to the motion. So I'll try to illustrate this on my velocimeter as well. Let's say we have an initial velocity that's in the positive direction, and then an acceleration that's positive as well. So it moves to the positive end over here. That object is speeding up. So we say speeding up. If we have a negative initial velocity and the acceleration is negative, we're speeding up again. So negative initial velocity, negative acceleration, speeding up again. So if they are the same, so initial velocity and acceleration are the same, then that means you're increasing your speed. You're becoming more of that thing, getting further and further from zero. Now, for the opposites, if you're moving in the positive direction and your acceleration is towards the negative end of the velocimeter, that means you're going to be slowing down until you hit zero. Right? So positive velocity, negative acceleration, you're slowing down. And likewise, if you start out with a high negative velocity and you have a positive acceleration, you're moving towards the zero here, becoming less negative. And so you're starting out high speed, but positive acceleration and a negative velocity means you're slowing down again. So if it's opposite, velocity and acceleration are opposite, that means you're slowing down in both instances. We have a couple of other special cases here when you have an initial velocity, either positive or negative, and the acceleration is zero. That means you're just stuck on whatever velocity you're at. And so we would call that kind of motion constant velocity. On the other hand, if you had zero starting velocity, you're right here at the 0 point on our velocimeter, and you have any kind of acceleration, either negative or positive, what that means is you're speeding up, because right here is the slowest you can go at rest. So if you go either way on the positive end or the negative end of our velocimeter, you're going to be speeding up. So zero velocity, either positive or negative acceleration, means you're speeding up from rest. All right, let's look at one last example. The end of this. Quick word problem here. A long distance runner jogs west at 3 meters per second. He sees the finish line and speeds up to 5.5 meters per second in 2 seconds. What is his acceleration? All right, so let's do the guess method here. I've drawn a little sketch. It's usually helpful to draw a picture of these kind of things. It's helpful in this case because it helps to show what direction he's moving. It says west, so I drew him running to the left. And so because of that, I can identify the initial velocity as 3 meters per second west, or negative 3.0 meters per second. He's moving this way. Then his final velocity, he speeds up as he's moving towards the finish line. So his final velocity is even faster. He's gone from negative 3 to negative 5.5. And that happened in 2 seconds. What is his acceleration? We're going to use this equation over here because it's got both my final and initial velocities in it. And so it's easy to figure out the difference in the velocities here. So I'm going to substitute in for final velocity, negative 5.5. I'm going to keep that negative sign in here because this is important for vector quantities. We have the initial velocity of negative 3. So we have minus a negative here, and that's going to be a little interesting down here, because whenever you have negative 5.5 minus negative 3.0, that ends up turning into negative 5.5 plus 3.0. So two negatives make a positive. So we end up with, add those together, negative 2.5 meters per second is our change in velocity, and our time was 2.0 seconds. So our acceleration at the end here is negative 1.25 meters per second, or negative 1.3 meters per second if you round it to the appropriate number of sig figs. So that's all I've got for you in this video. Remember, everything you have is a gift.